So continuing the discussion of polynomials and looking specifically first at monomials. So remember, a monomial was a polynomial with only one term. Okay. So actually we start out with some really basic examples here. So actually we're really just looking at constants here. So I need a rule. So do you remember the exponent rules comparing like number 1 and 2 here? So if I have a base to the m times the same base to the n, I add those exponents. Versus if I have a power to a power, I multiply those exponents. Okay. Shall I add? I guess I can add one more here. If I have x to the m divided by x to the n, I subtract. Okay, so here I have some exponent rules. Okay, so let's see, looking at number 1 over here, I can use the first rule. I have the same base multiplying, I add the exponents. Okay, versus in number 2, I have power to a power. So I multiply. Okay, here's another one, power to a power, except the base is a variable. Same thing. Okay, so here I have a little bit fancier looking monomial. Still got just one term, but I've got two factors in there. I've got the -6 and the x cubed. So this exponent has to distribute to both factors inside. So that'd be -6 squared times x cubed squared. Now remember, -6 quantity squared is -6 times -6. That's positive 36. Power to a power, I multiply. All right, same idea. All of these guys are multiplying. I have 3 factors. Distribute the exponent to all 3. Okay, so when I have a negative number raised to an even power, that's going to be a positive, right? So I can tell you right away, this is going to be positive 16. If you wanted to write it out, you could. That'd be positive 4 times positive 4, right? Power to a power, I multiply. 2 times 4 is 8. 3 times 4 is 12. Okay, so let's see what we have here. So here I have a multiplication. So I have -n to the 6th times 5 to the n, or times 5n. Okay, so multiplying all 3 of these factors. I can rearrange, put my n's next to each other. So if I have just plain n here, that's n to the power 1, right? So I add the exponents. Okay, number 7, again, I can rearrange. I really have 4 factors here. Can multiply those in any order. So let me put the constants in the front here. Like so. Okay, let me see. Shall I do some side work here? Let me look at these fractions. So what does that leave me with? 1 over 6. Okay, and then y to the 5 plus 6. Okay, number 8, power to a power, multiply. Let me go ahead and distribute this exponent to both of those factors. 2 squared and then m to the 4th squared. Okay, now I actually have like terms since these are both the same power. So look, I have 1m to the 8th minus 4m's to the 8th. I have negative 3m to the 8ths. Okay, let's see here. So let's see, I have, let me rearrange. 3 times negative a times a cubed plus, let me distribute that too. So negative 3, and then I have a to the 1, and then a cubed plus 9a to the 4th. Okay, so negative 3a to the 4th plus 9a to the 4th. And I actually have like terms there again. So that gives me 6a to the 4ths. Write an algebraic expression for the area of the rectangle. So if you remember from geometry, for a rectangle, the area is the length times the width. So those two quantities are given here in terms of the variable a. So we would just multiply those. Okay, so the area would be 48a squared. And that's the last one.